Welcome, everyone. Thank you for joining us tonight for the Deep Space Sky Tour. My name is Anna, and I manage adult programming for the Lake Bluff Library. If you're joining us tonight because you like nature, then I suggest you check out next week's program on the Owls of Lake County. And if you're here because outer space sounds like a great escape from the current world, maybe you'll like our History of the Cocktail program next Thursday. So I'm going to let Wayne jump in here, and questions will be held to the end, and the recording will be available on our YouTube 1 to 2 days after tonight's program. All right, take it away, Wayne.
Wonderful. So hello, everyone. My name is Wayne Foster. I am a planetarium educator here at the CERN and Earth and Space Center at Triton College in River Grove, Illinois. And what we're going to do today is we're going to take a quick look at some of the stuff that you can see in the nighttime sky tonight. So if you go outside tonight right around 10 o'clock, hopefully it's not too cloudy out there tonight, you'll be able to see all of these stars and objects that I'm going to be showing you. And hopefully I'll give you a good idea of where you look and sort of how you can track your way from one to the other. So if you go out into your backyards, you'll be able to really get an idea of what you're looking at and what you can see. And hopefully you'll be able to see some of those. And then once that's all done, then I can answer any questions that you might have, whether it be about anything that we saw in the program, anything that you have wanted to know for a little while about space or science or planets or stars or even aliens or UFOs or any of that kind of stuff. I'll do my best to answer any questions that you might have. I'll just hold all those till the end and we'll have some time for that as well. But for now, we're going to switch over to our sky simulator software. I use a program called Stellarium. It's a free computer program that you can use, download on your home computers and use it to learn your night sky and follow along with me today if you want, or you can just spend some time to figure out where things are. There are also all sorts of cool apps you can get for your phones or tablets or other devices that will help you track the sky and give you a better idea of what you're looking at. But we're going to switch over to that right now. So here we go. And now we are looking at the CERN and Earth and Space Center is right here in front of us. This is the building I'm sitting in right now. We're kind of in a field right in front of it. And the magic of this program lets me set it to whatever date and time that I want to. And so right now we're set to today, July 27th at about 10 o'clock in the evening. And that's about 2 hours after the sun sets, which is really the best time to go out and take a look at the nighttime sky because the sky is nice and dark then. If I have time go backwards just an hour to about 9 o'clock. Oops, that was the wrong way. There we go, backwards to 8 o'clock, 9 o'clock. We see there's still a lot of twilight left in the sky here. So we can see some stars a little bit, especially if we look away from the sunset this way. We can see some stuff popping out there, but there's still a lot of light coming from the sun. And it makes it too hard to really see anything. So you want to wait until it's nice and dark, about 2 hours, hour and a half after the sun sets. And then you'll be able to really get a good look at some of the bright stars and objects that you can find out there. And if we take a look around now, we can see that there are maybe 100 or so stars on a nice clear night that we can see here in River Grove. But that's about it. We can only really see some really bright stuff. And that's because we're so close to the city of Chicago. I know that you all up there are pretty close to the city as well. And so you have the same problem that I have here in River Grove, and that is that being close to a major city or being in any lived-in area, you're around a lot of people. And people, well, they need light to see things. So we have car headlights and neon signs and street lamps and building lights and everything that helps us so we don't crash into stuff while we're walking around at nighttime. And that's all very important to us, but it does create a problem that we call light pollution. Light pollution is that sort of orange or bluish haze that you'll find around any major city or lived-in area. And it makes it so we can really only see the brightest of the bright stars, which is rather unfortunate because there's so many cooler things that we can see out there if we could just get away from all of that light pollution. And you can do that if you go out west, go way out into the countryside somewhere. You can go as far as some of the national parks, the deserts way out west, or go out onto the lake. If you're lucky enough to have a boat or some sort of way to get out onto the lake, go maybe 30, 50 miles out onto the water, and then you'll start to see a lot more because you're far enough away from those city lights. And I can show you what that will look like by turning off all of our atmospheric interference here. And now we can see thousands of stars in the nighttime sky. And we can see the beautiful Milky Way stretching across the sky as well, something that we don't get a chance to see here around Chicagoland. And there's a lot more to see. In fact, there's so much to see that it kind of makes it hard to discern one thing from the other. There's hard to connect the dots and make all of the shapes that we are so familiar with, because there is so much out there and it's a bit distracting to see all of the other stuff. And so having the atmosphere and the light pollution does help us a little bit when we're trying to learn the nighttime sky and see where things are. It helps us see only the brightest of the bright stars, which is the ones that we're looking for when we search for constellations and those sort of stick figures that we look for when we're learning the nighttime sky. And those will be what we look at for most of the show here. We're going to take a look around and see some of them. Like I said at the beginning, we're in the middle of summertime, so we have some summertime stars, but I want to show you some other ones first, some of those ones that are visible all year round. And one of the first of those that should stick out to you is this group right here, 7 very bright stars that form a very recognizable and easy to find shape in the sky. We know it as the Big Dipper or the Big Spoon. It does have different names in many different cultures around the world. Some places call it the drinking gourd, some places call it the wagon, all sorts of different things depending on where you go and who you talk to. But most people in the United States know it as the Big Dipper or the Big Spoon. It's actually part of a much larger shape in the sky, which includes all of these stars as well. And we call that shape Ursa Major, which means the Big Bear. Now, this looks kind of like a bear, but we'll get into that in just a second. What I really want to show you using the Big Dipper is that you can use it to point your way around the sky and find some other cool things out there. And I'm going to show you how you can use it to find a very important star in our nighttime skies, probably the most important star in our nighttime skies. If you use the 2 stars on the end of the bowl of that Big Dipper, draw a line between them and continue following that line away from the spoon, it will point you right towards this star right here at the end of my mouse pointer. Now, that star is called Polaris. You might know it a little bit better by its other name, which is the North Star, and it is a very important star. Not because it's so bright. A lot of people think that the North Star is the brightest star in the nighttime sky, and that is unfortunately not true. It's actually barely breaking into the top 50 bright stars in the sky. What really makes it so important to us is just its position in our skies. Our North Pole is pointed almost directly at that star. So as the Earth spins around that axis, all of the other stars will seem to move through the sky, but Polaris stays right in the same spot, almost pointing us directly to the north, which means that if you ever get lost in the woods, or deserts, a parking lot, or whatever, you can find the North Star, and then you know what direction you're facing, and hopefully you know what direction you need to turn from there. Now, if you don't know what direction you need to turn, that's okay too. Just stay put, don't move. I am sure that someone is looking for you, and hopefully they'll find you eventually. But if you do find that North Star, now you know that you're facing towards the north, and I can show you that that North Star does line up. If I turn on my cardinal points right here, it lines up almost directly with due north right there. So anytime you find that star using the Big Dipper, point right to it. Now you know what direction you're facing. And it's also on the end of the handle of the Little Dipper, which we can see right here. Now, the Little Dipper is what we call this shape, but again, it has many different names from different places all over the world. And its official name is Ursa Minor, which we know based on our wonderful deduction skills that means little bear. So here we have the 2 bears in the sky, the big and little bears. And this one looks more like a bear, the Big Bear does. This one doesn't at all, but I can bring up some artwork to help you see those a little bit better. Here we go. And now we can see, well, they kind of look a little bit more like bears, but still there's something wrong with these 2 bears. And that is the fact that they have tails, especially these very long tails. We all know that bears have short little stubby tails, but there is a reason that these 2 bears do have those very long tails. And it has to do with how these pictures got started a very, very long time ago. And you have to remember, not that long ago, people didn't have things like the internet or cell phones or Netflix or video games or any of the fun stuff that we have today. So, in order to have a good time, people would go outside, look at the stars at night, and make pictures in those stars. And then they would make up stories to go along with those pictures. And that's where we get these two bears from a story from ancient Greece from thousands of years ago. The short version of that story is that people wanted to put the bears into the sky so that they could live there forever, but they weren't quite sure how to get them up there. So they found the biggest and strongest person they could find, who grabbed those bears by their stubby little bear tails, swung them around in a circle really, really fast. And when they were going fast enough, they let go and the bears flew up into the sky and got stuck. But while they were swinging them around like that, their tails got all stretched out. And that's why these two bears have those long tails. I'm the first to admit that that is a pretty ridiculous story. Please don't try and grab a bear by the tail because that is just a very bad idea. But I do like that story a lot because it does show us that not only can we see whatever pictures we want to see in the sky, we can also make up whatever stories we want to go along with them. You don't need any special tools or anything like that. All you need to do is to use your imaginations. Go outside and make up some crazy pictures, make up some stories, and pass them along. That's the important part. Many of the pictures that we're going to be going over today come from ancient Greek and Roman mythology. And like I said before, we know that many cultures around the world historically have had pictures in the sky that they have made up and made stories about. But a lot of them, we don't really know what those pictures were, or we have a base idea of some of them. We don't know all of them. The reason that we do know many of the Greek and Roman ones is because they were written down and categorized and cataloged. They were put together into a catalog by a man named Ptolemy, who charted the sky and wrote down what all of the pictures and constellations were. And those are passed down through Western science. And so those are the ones that we still use today. They're the official constellations that scientists use. But there's nothing stopping you from making up your own. You just have to remember that nobody else is going to know what you're talking about when you start to rattle them off. So the important part is to pass them along, write them down, come up with your crazy stories. And then maybe 2,000 or 3,000 years from now, people will be telling your stories when they look up at the sky. Could be kind of fun. Now, these two groups of stars, the Big and Little Dippers, they are what we call circumpolar groups of stars because they just circle around Polaris. We also have another group of circumpolar stars over here. It's sort of this W shape. It's visible all year round. It is called Cassiopeia, and she was an ancient queen. There's a whole story associated with her, but it doesn't really come into play until mid-August, or I'm sorry, mid-autumn. So there'll be more groups of stars coming up that are associated with Cassiopeia here and her mythology story as well. But you can always see Cassiopeia here in the sky. And they'll just circle around Polaris. They'll move around in the sky, but all year round, they'll be visible from most of the northern hemisphere. But everything that is behind us right now, everything towards the southern part of the skies, well, those stars change depending on when you go outside and take a look. And right now, like I said, we're in the middle, coming towards the end of summertime. And that means we have a lot of summertime stars for us to take a look at. So let's turn around and take a look at some of those. So we're going to turn and face towards our west, where the sun just set a couple hours ago. And just a little bit higher up in the west, not too far away from that Big Dipper, we see a very, very bright star in the sky right here. Now, this bright star is part of one of my favorite shapes in the entire sky. It's sort of a half springtime, half summertime group of stars. So it's visible throughout the summertime, but it starts being visible in mid-spring. And it's one of my favorites because to me, this shape looks a bit like a milkshake or an ice cream cone. And on a hot summer's day like today, well, a milkshake or an ice cream cone sounds really good. And so I like to think of this one as being the milkshake in the nighttime sky, but that's not what it's supposed to be. That's just what I like to see up there. This is actually supposed to be a person. He's a shepherd in the sky. His name is Boötes the herdsman. I'll bring up his picture so we can see him. There he is. And he is said to be shepherding the great bears, Ursa Major and Ursa Minor, across the nighttime sky. And so he's making sure that they keep moving and the earth keeps spinning. So that is Boötes the herdsman, and he'll be almost directly towards the west, a little higher up in the sky. Now, if we keep turning around, we will face towards the south, and there are a couple of really cool shapes that we can see in the southern part of the sky tonight. The first one is going to be this shape right here. Let me bring this up. Let me actually get rid of the ground here so that we can see the whole thing. There we go. So this one has a couple of different names. We know it officially as the scorpion, Scorpius, up there in the sky. And you can see it does kind of look like that. You have sort of the head and the pinchers up here at this end, and then the tail and the stinger comes around to this end here. I'll bring up the picture really quickly so we can see that. There we go. Does kind of look like a scorpion. But this one, again, has different names from different parts of the world. And one of my favorite names for this group of stars is the Chief's Fishhook, which was a name given to it by Hawaiian Islanders and other Pacific Islanders. They called it the Chief's Fishhook, which you might know a little bit better as Maui's Fishhook. If you ever saw the movie Moana, put out by Disney Pixar, they refer to Maui's Fishhook, the group of stars. That's the one that she uses to help navigate her way across the ocean. And that is this same shape that we know as Scorpius the Scorpion. And it was used as a navigational aid by Pacific Islanders. So that's a great example of how different cultures see different things in our nighttime sky. So that's right here towards the south. Let me put the ground back up so we can see about where that would be off of the horizon. And it has a bright red star. Let me zoom in a little bit on this. So right here near the body, before it splits off into the pinchers and the head, is a bright reddish looking star. And the constellation of Scorpius is one of our Zodiac constellations. Zodiac constellations are called that because they sit along the ecliptic line, which is the path that the sun and the moon and the planets all take throughout the sky. It's sort of the plane of our solar system. And so that ecliptic line, where those objects pass through, those constellations held a lot of importance to ancient cultures because they worshiped the sun, the moon, and the planets as representations of their gods. So where their gods were walking around in the sky was very important as to what was going on in their heads. And this star is a sort of reddish looking star. It actually looks very similar to the planet Mars, which sometimes passes through this area. And since it looks a lot like Mars, it could be easily confused, especially if they're close by one another. So in order to help tell the difference between the two, the ancient Greeks called this star Antares, which means not Ares, or as the Romans would later call Ares, the god of war, Mars. So this star's name is literally not Mars. I don't know how that is exactly supposed to help us tell the difference, but I guess if one of them is moving around in the sky and one of them stays in the same spot, well, then you know which one's the planet and which one is the star. And so that is Antares, the brightest star in the constellation of Scorpius, the Scorpion. Right next to Scorpius, we have another bright zodiac group of stars. That is this one right here. It's a pretty big, strange looking shape. This is actually Sagittarius, the archer. He's a centaur, so he's half man, half horse. And I'll bring up his picture so we can see him. He's got his bow and arrow pointed right at Scorpius, the Scorpion. Now, Sagittarius, the archer here, is kind of bright, especially these stars in the middle. And those are the most important ones that I want to talk about right now. This sort of central shape, we call this the teapot of Sagittarius because it looks a bit like a teapot. You have the spout here, there's the lid and the handle. And we can use this shape to point our way around the sky, kind of like how we used the Big Dipper to help us find north. If we use the spout of that teapot, it forms an arrow that's going to point us right towards this, what looks like to us, this sort of empty patch of the sky right here. But that's not really a very empty patch. It just looks that way to us because of all of our light pollution around this area. In fact, that's that arrow that we just made is really pointing us right towards the exact center of our Milky Way galaxy. That's the heart of the galaxy that we live in. In the center of the galaxy, there is at least one, maybe several supermassive black holes. And those are black holes that are so tremendous and have such strong gravitational force that the entire galaxy rotates around them. But you can't really see that because we have so much light pollution. But if I turn off our light pollution once more, now we can see that this bright arrow here does point us right into the heart of the Milky Way. And then you can imagine the rest of that cloudy band of our galaxy stretching across the sky. Well, that is just the steam rising out of the teapot. So you can use the constellation of Sagittarius, especially this little part that we call the teapot. Well, you could use that to point your way so that you know that you're looking at or towards something that you might not necessarily be able to find in our nighttime sky because of all of our light pollution that we have here. So you'll know you're looking right at the heart of the galaxy, even if you can't see it. Now, this is all towards the horizon, which makes it a little bit easier to spot because you don't have to look too high up and you kind of know what direction you're facing. But there is stuff much higher up in the sky. In fact, if you look almost directly overhead, then we'll see a group of 3 very bright stars, which we can find right here. Those 3 bright stars form this nice bright triangle shape that we can see. And we call that shape, since astronomers are so creative when they name things, the summer triangle, because it's a nice bright triangle that we can find in our summertime skies. But the interesting thing about this shape is it's what we call an asterism. Now, an asterism is a group of stars that forms a very well-recognized shape in our skies, but it's not quite the same thing as an official constellation. In fact, this asterism uses 3 stars from 3 separate constellations in our sky. So let's go through those 3. We'll start here at the bottom. This bright star is called Altair. It's the bottom point of our triangle, and it's part of the constellation of Aquila the Eagle. I'll bring up the artwork here so we can see Aquila the Eagle. There he is. Now, Aquila was sort of the Labrador retriever of Zeus, the king of the gods. He would fly around and get anything that Zeus wanted and bring it back to Mount Olympus for him. It would carry his lightning bolts, so when Zeus got mad, he can smite the mortals down here on Earth. And he just kind of did whatever Zeus wanted him to do. And then if we work our way around, then we'll come up to this point of our summer triangle right here, the top left point. And this is part of this shape here. The star is called Deneb. Now, this shape is sometimes called the Northern Cross. So if you look up in the sky, its brightest stars make up the head, the center, the bottom, and then the 2 arms of the cross right here. But its official name is actually Cygnus the Swan. And we can see it does kind of look like a swan. We have the head and the long neck here, the tail coming out this way, and then the 2 broad wings. And I'll bring up the photo for that. There we go. And there is Cygnus the Swan. And this is actually Zeus himself turned himself into a swan to go down and mingle with the mortals here on Earth. And so that is the swan that Zeus turned himself into, was Cygnus the Swan. And then the last point of our summer triangle is almost directly overhead tonight at 10 o'clock. It is one of the brightest stars that you will see in the sky tonight. It's called Vega, and it is in the constellation of Lyra, the harp, which doesn't look much like a harp. I like to think of this one as sort of the juice box in the sky, or maybe a walkie-talkie, I guess, could be that as well. But it is supposed to be a harp up there in the sky. And this is what the photo looks like for that, or the artist's representation of Lyra the harp up there. So if I zoom out here, we'll see we have a pretty good number of bright stars. There's one more group that I want to point out to you before we look at some other things. And that is going to be this group that's just starting to rise up over here. Let me make sure I'm clicking on the right one. Yes, there we go. So this one that's just starting to rise up is a autumn group of stars. It is one of our fall constellations, and this is Pegasus the Flying Horse. Now, you can't really see it very well because the ground's in the way, but if I get rid of that, we'll see this great big square. It's called the Great Square of Pegasus. It's made up of 4 bright stars. That makes it really easy to spot. And then we have the head and the 2 front legs coming up this way. I'll bring up the artwork so we can see that beautiful flying horse in the sky here. But around 10 o'clock tonight, it's not going to be entirely visible, just coming up out of the east. And that's because it is more of a fall time star. So if you want to see it bright and high overhead, well, just wait another month or 2 and it will be much more visible. Now, there are other things that we can see in the nighttime sky besides these beautiful stars and shapes that we can find and make here. And those are the planets. Now, as I said towards the beginning, we can see a total of about 6 planets. You can always see the planet Earth if you look straight down. That will always be visible, and it helps to remember that we are on a planet just like all of the other ones that we see in the nighttime sky. We're still flying around the sun, just like all of those other ones. But there are other things that we can find, and tonight you'll be able to see a couple of those planets. I'm going to get rid of all of our lines and artwork here. And one of those is going to be visible at 10 o'clock just here towards the southeast. It's going to be very, very bright, and that is the planet Saturn. There will be another planet that you can spot tonight, but it's not quite going to be visible at 10 o'clock. You'll have to wait a little bit longer. So I'm going to fast forward time a little bit here till about 11 o'clock. And then we'll see Saturn has moved a little bit more towards the south end of southeast. And then coming up right where Saturn was at 10 o'clock, now we can see Jupiter as well. So both of these planets are quite visible with the naked eye. Jupiter will be very, very bright, and Saturn will be very bright as well. But Jupiter will really kind of knock your socks off. It's so bright and easy to spot in the sky. And you can see them with the naked eye, but they do look so much cooler if you can get a good set of binoculars or a halfway decent telescope and take a look at those. I can kind of show you what that will look like if we take a look at Saturn through sort of your basic set of binoculars or backyard telescope. Now you can see Saturn there, and you can see a couple of the moons that surround that planet as well. And then the same thing for Jupiter. Sort of look here to see Jupiter there. And then we see 3 of its 4 largest moons. We call them the Galilean moons because they were discovered by Galileo almost 400 years ago. So they were discovered quite a while ago with the first telescopes that were made. And those all go around the planet Jupiter. So with a good pair of binoculars, that's about the view that you would get for those. But we can do a little bit better here because we have this fantastic planetarium software. And so instead of using our binoculars view, I'm just going to zoom us straight in, and we'll take a nice close look at these 2 planets. So this is what it looked like if you have a pretty good backyard telescope. It doesn't need to be a professional quality telescope to see things like this. And we could start to see the banded clouds of Jupiter. Jupiter is a gas giant planet, so it's made mostly of hydrogen and helium gases. And those gases make clouds, just like the gases here on Earth make clouds for us as well. And they're slightly reddish in color. And if you are lucky enough, it looks like we can't really see it right now at about 11 o'clock tonight. But sometimes you could even spot the great red spot in the atmosphere of Jupiter. And that's actually a hurricane that has been raging in the atmosphere of Jupiter for, well, at least the last 150 to 200 years. It is starting to get smaller and a little bit less red than it has been observed in the past. So we think that that storm is starting to die out a little bit, but it can still be spotted pretty easily with a backyard telescope. And we can also see some of the moons of Jupiter. So we have Ganymede, Europa, and Callisto are all visible. Now the 4th of the Galilean moons is Io, which is going to be behind Jupiter from our point of view right now. You won't be able to see it, but maybe if you go out tomorrow or the next night, you'll be able to see Io a little bit better as well. So you can see Jupiter and at least 3 of its moons if you go out tonight and look at it through a telescope. But really, the coolest one to look at is Saturn. If you look at Saturn through a telescope, you'll also be able to possibly see several of its moons around that planet as well. But really, what will stick out at you are those beautiful rings that Saturn is so famous for. And we get a good look at them here. And this is pretty close to the view that you'd get through a decent backyard amateur astronomer's telescope. So you can get some really fantastic images of those rings just from our own backyards. You don't need super expensive, super fancy equipment to do this. And Saturn has beautiful rings, but so do the other gas giant planets. And that includes Jupiter, and then the 2 planets that we can't really see with the naked eye, which are Uranus and Neptune. All of those planets have ring systems around them. But the other 3, Jupiter, Uranus, and Neptune, their ring systems are made out of dirt and dust particles. So they're kind of hard to spot. We actually didn't know that they were there until, well, not that long ago, maybe in the last 10 years or so, 10, 20 years, we discovered those ring systems. But Saturn, well, we have known about those ring systems since it was first looked at through a telescope. And that's because Saturn's rings are made out of chunks and bits of ice debris, just like a bunch of ice cubes floating around that planet. And ice reflects light much better than dirt and dust does. So Saturn's ring bounces all of the sunlight back to us, makes them much more visible, much more majestic. And it's the reason that Saturn is one of the most recognized and many people's favorite planet, because that is going to be very easy to see those, even through a good set of binoculars or a halfway decent backyard telescope. So those are all some of the things that you'll be able to see right from your own backyards tonight. There are other cool things to find if you want to delve more into astronomy, get better equipment, and start looking at deep sky objects. And to see some of those, what I'm going to do is I'm going to turn off our atmosphere and our ground here. And then we can see the Milky Way starting to show up. And if we zoom in a little bit more onto certain areas like Sagittarius, the Archer, we start to see these sort of patches of color around here. And there are some interesting ones around Sagittarius and in the path of the Milky Way. And these are what we call nebulae or nebula. And they are just clouds of gas and dust. And they are where new stars and planets are being created. So basically what happens is you have this sort of big cloud of hydrogen gas and dust particles, and 1 or 2 of those atoms will collide into each other and they will get stuck together. And since they're stuck together, well, they're a little bit heavier, and heavier things have a stronger gravity. So they start to pull more stuff in towards them, and that gets stuck together, and it's all bouncing around and colliding with each other until eventually stuff is so compacted and colliding with each other with such energy and such frequency that the atoms of hydrogen start to fuse together and they form a new atom of helium. And once that happens, well, then you have started the process of fusion, and that is what makes something a star, when it starts to fuse 2 atoms into a new element. And so these areas of the sky, these nebulae, these are the stellar nurseries. These are where those processes happen. And this is where we get new stars and solar systems. So our solar system was created in a stellar nursery just like this one about 5 billion years ago. And we could see that process in action throughout the sky. We see these nebulae strewn about and creating new stars. And there are some very interesting and active ones in our wintertime skies in the constellation of Orion. Some that are even visible with the naked eye on a nice clear night in a very dark area. So I definitely recommend you check those out in the wintertime as well. But that's about all that we have for our nighttime skies tonight. So I will switch back over to my webcam view here and use whatever time we have left in our program to answer any questions that you might have. So if you have anything that you saw that you want to know more about, please feel free to, you could type it in the chat or just ask it, or however the library usually does their question and answer format. But I am more than happy to answer whatever questions you might have.
Yes, absolutely. We'll give people a few minutes here to work in the chat. I was curious when you mentioned the Zodiac Constellations and you said they're all along. What was the name of that line?
It's called the ecliptic line, and it's the plane of our solar system. It's the path that the sun, the moon, and the stars all take, or I'm sorry, the sun, the moon, and the planets all take through the night sky as the year goes on. And so it's just that has given it weight. I know a lot of people like to look up their horoscopes based on their zodiac signs, and that all stems from watching the planets and the sun move across the sky, and they cross through those areas. And like I said, the ancient people, they worshiped the planets and the stars as their gods, and that's actually where we get the name planet. It comes from a Greek word planetaris, which means wanderer. Those were the objects that wandered around the skies. And so the ancient Greeks thought that those were the gods wandering around in the heavens. And so where they were, depending on what time of year it was and where they were as they were wandering around, well, that said a lot about what mood they were in. And that said a lot about what your life was going to be like. And so they plotted out people's futures based on those observations. And so that kind of evolved into our modern study of astronomy, where we observe the nighttime sky. It all started from astrology, which is not exactly a science, but it is still fun to read your horoscope in the newspaper.
Absolutely. Thank you.
Mhm.
Did anyone have a question they'd like to turn their microphone on to ask?
I did get a question directed towards me from Tony that I think would be good to address for everybody. He asked for any recommendations on a decent binocular set or telescope to observing the planets and stars. And I don't have a particular set that I like to recommend because it really depends on your situation and how deep you want to get into it. So I always recommend starting out by just looking at the sky, learning where things are, learning the constellations, watching the planets as they go across the sky over the course of a year, and then moving up towards binoculars. And just a set of field binoculars is good enough to kind of see some things, but you'll want some pretty hefty, powerful binoculars to get a good look at some of the deeper stuff like planets. But any set of binoculars will help you see a little bit more. But a really good set of the big hunting type binoculars, those will work well. And then from there, you can decide if you want to get a telescope. Well, then you have so many options available to you that it can be kind of hard to choose. But you want to start with something that you're going to be comfortable learning how to use. So start with something basic. There are some very good travel scopes out there that you can use during the daytime and nighttime for wildlife spotting or things like that, and then use it at nighttime to look at stars and the moon and the planets and things like that. So start with something like that, and then you can upgrade towards things like the bigger Dobsonian mount, big bucket telescopes that are a little bit more difficult to move around and get to use. But if you're going to be using it in just your backyard, then that makes it a little bit easier. If you want to travel around with it, then you want something light and easy to carry. So yeah, and then just do your research and find out, which brands are recommended. There are tons of astronomy communities around and people who will help you make that decision, whether that's online or in person. I know that there are several amateur astronomer groups in and around the city, including the Chicago Astronomical Society. And I know that there are a lot of suburban astronomical societies as well. And their members are usually pretty helpful in helping people get started with telescopes. I see Sharon has asked, have the forest fires created any difficulty in seeing the night sky? And the answer is yes, they have. I don't know if you travel to and from the city at all, anybody, but if you do, you'll have noticed that the skyline has been looking particularly hazy the past couple weeks. And that is because of the smoke from the forest fires out west. It is traveling all the way across the country, reaching as far as New York and making things look a little bit hazy in our nighttime sky, or in the daytime skies even. And that does translate over to the nighttime sky as well. It creates atmospheric interference, the same thing that clouds would do for us, or high humidity or something like that. All of those things can affect what we call the seeing. Uh, that is the term that we use. What is the seeing like? And that is basically how well can you see things in the nighttime sky. So yes, the forest fires have had an impact on that, and hopefully that gets under control and doesn't last too much longer. Not only for our nighttime sky visibility, but also for all the people out west who are affected by those fires. But yeah, it can create some problems when looking through telescopes and looking at the nighttime sky. What should you look for in the coming months? So most of the groups of stars that we talked about will still be visible over the next few months. Boötes, the herdsman, he's going to set in the eastern part of the sky pretty soon, probably the next couple weeks. But Scorpius and Sagittarius and the summer triangle groups, those will be visible for the next couple months. You'll start to see Pegasus and a few more of the autumn constellations, including Andromeda and Perseus, will start to become visible in the nighttime sky. Saturn and Jupiter will move up towards the south, so will be visible earlier and earlier as the months go on. So if you go outside in, say, a month's time, they'll be visible around 9 o'clock at night instead of waiting until 10 or 11 o'clock at night. So you'll still be able to see those for quite a while yet. And then a few months later from that, then we'll start to be able to see Mars in the sky once again towards the south. And all of those planets will be along that that ecliptic line that kind of stretches from the east to the west through the south. Excuse me.
And do we have any upcoming specific phenomena, meteor showers, partial eclipses, anything we should set?
Yes. So there is actually, let me double check the date on this. But the meteor showers occur cyclically. So they happen at the same point of time every year for the most part. And so the next big one coming up is the Perseid meteor shower. And it's actually happening right now because it stretches for almost a full month. I think it started sometime maybe a week or so ago, and it'll go through about the middle of August. And so that is a very active meteor shower. So if you get dark skies, if you can get to a dark sky area, then check that out sometime in probably the second week of August, around August 11th, 12th, 13th. That'll be the peak of the Perseid meteor shower. You'll want to go out a little bit before sunrise. That'll be your best time to be able to see those. And you can see sometimes as many as 100 or so meteors per hour during that meteor shower. So definitely get out and try and take a look at that if you get a chance to. That is going to be the sort of the big event for this upcoming month. Do the other planets have supermoons? So a supermoon is what we call our full moon when it is at its closest point in its orbit. So yes, theoretically, other planets do have supermoons because their moons all follow an ecliptical orbit around them. So any planet that has moons can have a supermoon as well. It's just that point where it is closest to its parent planet. It won't look quite the same thing. We are actually kind of lucky with our moons, or with our moon, because it is so big relative to the size of the Earth. And it's also kind of at the perfect distance away. So the moon is about 400 times smaller than the sun, but it is about 400 times closer to the Earth. And so we are lucky in that when we are living right now, as the moon passes in front of the sun, it is at the perfect sort of perspective to block it out completely. And that's why we can get a total solar eclipse, where the moon covers up the sun entirely. But other planets, well, they don't really have that because their ratios are not the same. So even if you could stand on the surface of Jupiter, its moons wouldn't block out the sun. Well, they probably would block out the entire sun because it is so much farther away from that planet. If you were standing on the surface of Mars, its two moons, Phobos and Deimos, are actually very, very small and very close to the planet. So they're not going to block out the sun, and they pass by very rapidly. They have very quick orbits around the planet Mars. So it's not going to be quite the same as we like to think of as our supermoon, where it lasts for the entire full moon cycle of about a day, day and a half. It would be a different time scale and a different sort of frame of reference.
So since you're on the subject of moons, you mentioned that Jupiter and Saturn have specifically larger ones, but are there also smaller moons that orbit?
Yeah, so actually Jupiter and Saturn don't have just larger moons. They have some of the largest moons in our solar system, but they also have a lot of moons. And we're constantly discovering new moons as well. And it takes a little bit of time to confirm them. Some of them are captured asteroids that have been caught in the gravity of those planets. But in terms of numbers, Saturn has the most moons that we have discovered and confirmed in our solar system, and that is 82. And Jupiter is not too far behind. I think it has 79 confirmed moons right now. And so they have a lot of moons, and some of them are as big as our moon or as big as the planet Mercury. Some of them are as small as the moons of Saturn or even of Mars, or even smaller, about the size of asteroids. So it's because those planets are so humongous and have such strong gravity, that they can capture these objects and hold them in orbit as moons. And so there are a lot of them, but because those planets are so big, they also have the largest of the moons, objects that could be considered planets if they orbited around the sun instead of planets themselves. Someone asked if I have an app that I can recommend to view the sky. So the program that we were using, Stellarium, is a free computer app. You can download it. They do have a phone version, a phone and tablet version of that app, which works very similarly to the computer one I was using. Although I do believe that the phone version costs $1 or $2 in the App Store to download that one. But there are many other ones, including free ones that you can use. And really the only thing I can recommend, because there are so many of them, is to find one that has the features and the interface that you like to use. It's not too complicated for you. You can use it to point yourself around. Most of them have GPS and accelerometer tracking, so they can tell where you're pointing and where you're standing, and they'll tell you exactly what you're looking at. So just kind of take a look around, look at the reviews and the ratings on them. But there are a lot of them out there. I personally, like I said, I use the Stellarium one on the computer, and I have that on my phone as well. But I think Google has their night sky software. Apple might even have their own as well. And there are all sorts of other smaller programs that are out there that you can take a look at and just find one that fits your style, and find one that you like to use.
All right, well, if that's all we've got for questions tonight, we can go ahead and wrap it up. Thank you so much, Wayne, for your presentation. It was wonderful. I learned a lot about, especially the constellations. I've never been able to spot many of those, so I'm glad I know how to look for them now.
My pleasure. Thank you so much for having me. I hope you all enjoyed it. And yeah, the important thing is to remember to get out there and take a look at your nighttime sky. Before I go, I do want to plug our YouTube channel, where we post stuff similar to what we just saw here today, in smaller format, 5-minute videos of what you can find in the sky for that particular month, or take a closer look at certain objects or constellations. And you can find us on YouTube at the CERN and Earth and Space Center. Just look for that, and all of our videos should pop up.
Absolutely. And as I mentioned at the start, this one will go up on our YouTube in 1 to 2 days. We just need a little time for the computer to download and upload. So we'll get that up there. If anybody knows someone who wasn't able to attend tonight, or if you could think of another astronomy fan in your family you'd like to recommend it to. All right, thank you for joining us tonight, everybody. I hope to see you all again at the library soon. We are doing live viewing now, so if you feel like coming in here for the evening, I'm here. Our programming room is ready. Have a good night, everyone.